So this is the mechanics homework booklet question 13. We're told that the torque of a couple is given by that equation Fs, and we're asked with the aid of a diagram to explain what's meant by a couple. Label F and S on your diagram. So for a couple I need F and S, to be the same size of each other, to be in opposite directions, and to be separated by a perpendicular distance S. So that explains what the couple is. We're also asked to state the unit for the torque of a couple. The point is it's a force times a distance, so it's Newton meters, assuming you don't just know that, which I'm sure you do really. We're given a seesaw, shown in the diagram, consists of a uniform beam freely pivoted at the centre of the beam. Two children sit opposite each other, so the seesaw is in equilibrium. And explain why the seesaw is in equilibrium. It must be in equilibrium because the sum of the anti-clockwise moments is equal to the sum of the clockwise moments, really just a statement of the principle of moments. We're also asked to explain why the weight of the beam does not affect the equilibrium. If the weight of the beam is not affecting the equilibrium, then it must be immediately above the pivot, so the centre of mass must be immediately above the pivot. That is, that the weight is acting through the pivot, so that when I take moments, the moment of that weight is zero, because the perpendicular distance to the point I would be taking moments about is zero. We're then given the diagram with the seesaw loaded up with three children of weights 400, 250 and 200 newtons, sitting again so the seesaw's in equilibrium, and we're asked to calculate the distance d. What's nice here is all the distances are the distances from the pivot, so I haven't got to do anything clever with that. So I've just got to do the sum of the anti-clockwise moments is the sum of the clockwise moments. Anti-clockwise, what have I got? I've got that 400 at that distance, so there's 400 times 1 metre. I've got the 200 newtons. There it is, there's 200 newtons at a distance of 0.5 metres, and I've got 250 newtons at a distance d. There are those two. Now all I've got is an equation to solve, so I've got 400 is 100 plus 250d, so 250d is 300, d is 1.2 metres. That's the mechanics homework booklet, question 13.